In this video, we're going to ask about the basic stuff of existence. We don't necessarily need a theory about it, but it does help a lot philosophically if we can have some kind of sense of it in our minds. So, how can we best imagine it? There was a broad consensus about how to answer this question till relatively recently. At least, the one vision of reality was there in all the sciences, and in most people's common sense view of reality too. In this view, reality was basically a three-dimensional grid with matter in it. Space was a stage in which action took place, and the action was the movement of chunks of matter. Reality, therefore, conformed to Euclidean geometry, and seeing it in this way made it possible to calculate the motion of objects using straightforward mathematical formulae. Moreover, chunks of matter were often made from smaller chunks, which could be split apart and recombined. So we had a way of seeing things that paved the way for 19th century chemistry. There was little reason to question this view of reality till the early 20th century, when Einstein showed that matter, the chunks, and energy, the movement, were in reality two different aspects of the same thing. Let's call it potentiality. And experiments showed that the one portion of potentiality could function as a particle in some settings. If you shine a line in a solid, electrons will get kicked off the surface, just as if they were little particles that had particles of light colliding into them. But the same portion of potentiality will function as a wave in other settings. If you fire electrons through two slits and look at the distribution on the screen, you'll see an interference pattern, a phenomena of waves. Some physicists, exploring the best way to understand these and other phenomena that experimentation has brought to light, propose a whole new view of space, configuration space, saying, we consider the possibility that the basic space of physics is not space-time, but configuration space. This enables a deeper understanding of the geometric principle behind string theory and an insight in the currents of Yang-Mills and gravitational fields at the fundamental level. To appreciate how such a framework works, let's start with a simple example, a simple model universe that only has one dimension of space. We can imagine it as a tube in which things can exist, so they can be positioned towards the left or towards the right. In it, there's a single lump of potentiality, and it has no qualities whatsoever apart from its sitting in a particular place, and maybe moving right and then left. We can use a single axis to represent the single dimension of possibility. Then, the position of the x represents the entire state of this simple model universe. We can then use another axis to represent time, which is the only other dimension of possibility in the model universe. And a single line will represent the lump of potentiality moving right and then left. So, let's think about a slightly more complex universe, one with one more thing that can be different. Imagine that the lump of potentiality can be black or white or anything in between. That is one more dimension of possibility, so we need one more axis to describe the universe. Perhaps, at the start of the universe's history, the lump of potentiality is more or less in the centre and white. Perhaps it then moves right and stays white. Perhaps something about being so far right makes it then turn black, and maybe it then moves steadily back to the centre. Again, the evolution of the universe is described by a single line. A more complex universe would need more dimensions. A universe with 3 dimensions of space and 2 particles that could move around and change colour would need 4 dimensions for the first particle to describe its position in colour at any point in time, and 4 dimensions for the second particle to describe its position in colour, and 1 dimension of time, which gives us a total of 9 dimensions. In our reality, there are of course many more than 9 dimensions of possibility. This doesn't make any difference mathematically, for the mathematical treatments of configuration space work for any number of dimensions, but it can make the spaces hard to visualize and think about. Some dimensions run through every facet of existence. Every event in the universe, for example, happens at a particular time and in a particular place. So we have the single dimension of time and the 3 dimensions of space that we are all familiar with. Einstein showed that it is more accurate to think of these as 4 dimensions of space-time, and contemporary physics suggests that there are more than these 4 dimensions of possibility. Superstring theory posits 10, M theory 11, and according to bosonic string theory, there are 26. Other dimensions of possibility are local. The possibilities for grains of sand that exist on planets revolving around distant stars, for instance, have no impact at all on the way that events here on Earth evolve. So they slip behind a horizon of relevance, as it were, disappearing behind the dimensions which are relevant to what goes on. It's impossible to visualize the vast multidimensionality of the universe we live in, but it can be worth trying. If we ignore the dimensions of space, then we can imagine all the local dimensions of possibility as clusters of overlapping spaces. That leaves the vertical dimension free for time, the other universal dimension. And this allows us to picture the actuality of the universe as a ball of potentiality that tumbles down through the field of possibilities, inhabiting one set of possibilities and then another. It's not just the discipline of physics that has started to look at the world in this way, for ecologists have developed a startlingly analogous way of understanding the reality of ecosystems. In 1957, the Yale-based zoologist G.E. Hutchinson, a specialist in freshwater ecology, was examining the way different species coexist side by side. He looked at the environments that different creatures lived in and realized that there was more to habitat than physical space. There was temperature, pH, salinity, the time of day when the species were active, many dimensions of possibility. And he found that some species will always live, for example, in environments that are cold and acidic, while others will live in environments that are a little more alkali and a little warmer. Every species, he suggested, is associated with an ecological niche, a particular ecological space that it is able to inhabit. Every species exists in a slightly different space of possibility. Seeing possibility in terms of space can be a very powerful perspective, one that gives us insight into all sorts of aspects of the way reality operates. And interestingly, this way of thinking was prefigured early in the 20th century by the philosopher Ludwig Wittgenstein. Wittgenstein was looking for a fundamental way of understanding reality that would be philosophically useful. In his Tractatus Logico Philosophicus, published in 1921, he saw things being in a space of possible states of affairs. He was grasping at a way of seeing things whose time hadn't quite come. A speck in the visual field, he wrote, though it need not be red, must have some colour. It is, so to speak, surrounded by colour space. So, let's think of the world as a multidimensional landscape. It works. It does take time, though, and practice to learn to see the everyday world we live in this way. What is in front of us is always a lot more than a simple 3-dimensional physical space with objects sitting within it. That's a very static view of reality. In the new view of reality, space itself is dynamic and deeply structured. It is an intricate array of coherent possibilities that hovers in front of every moment, generated by that moment, and with unabating momentum, the universe trundles into one set of possibilities and then another, carrying us with it, and leaving the previous possibilities behind. There's more on possibility space on the website, and you'll also find the other 2 videos on the basic nature of reality there, one on life's intelligence and one on game structures. As always, comments and feedback are very welcome. Thanks for watching. Bye now.